Welcome to this explainer. Today, we're diving into a genuinely brilliant, life-saving technical mod. We're going to look at exactly how you can take your everyday, standard gas heater and completely transform it into a safe, modern, and incredibly reliable device. Let's get right into it. So, let's start with a scenario we literally all dread. Picture this. You're enjoying a nice, warm shower, and then suddenly, boom, the water goes freezing cold because the heater battery's just died. Or, honestly, even scarier, you touch the metal frame of the heater and feel a jolt of electricity. Yeah, no thanks. It's a shocking wake-up call, literally, and it's exactly why we need to rethink how we power these household essentials. In this explainer, we'll walk through why these terrifying failures happen and how to bulletproof your heater using modern lithium tech. We'll cover the hidden electrical charger danger, why the electronic circuit burns, the lithium battery and Type-C solution, the secret of the right voltage, steps for safe modification, and finally, saying goodbye to batteries and cords. All right, Section 1, the hidden electrical charger danger. So, the core of the issue really comes down to a dramatic mismatch of numbers. People get tired of buying D-cell batteries every month, so they grab an old internet router or TV receiver adapter pushing 12 volts. But here's the thing. They completely ignore that these gas heaters are strictly designed for a delicate 3 volts, usually drawing just 1 to 2 amps. I mean, 12 volts into a 3-volt system, that is a massive, massive mismatch in power. Which brings us to Section 2. Why does the electronic circuit burn? So what actually happens when you force that massive 12 volts into a tiny 3-volt system? Well, it causes a cascade of catastrophic failures. We're talking instant frying of the electronic circuit board, basically the heater's brain. You'll damage the digital display, burn out the gas solenoid valve, and you practically turn your appliance into a literal lightning rod during winter storms. The cost isn't just a broken heater, the risks here are absolutely catastrophic. And the most absolutely crucial point here is family safety. A tiny internal failure in a cheap adapter, something like a broken capacitor, can actually leak lethal 220-volt household electricity direct to the metal casing of your heater. This risks severe, potentially fatal electric shocks just by touching the water or the metal frame. We simply cannot compromise on this. It's just not worth it. Okay, let's move away from the danger zone. Section 3. The solution, lithium battery and Type-C. This is the ultimate future-proof solution that eliminates that 220-volt risk entirely. By combining an old laptop or power bank lithium battery, roughly 2,500 milliamp hours, with a modern 1-amp Type-C charging module, we create a completely isolated, ultra-safe power source. You just need those, 2 pairs of wire, and the original battery compartment or an empty case. The components are incredibly simple and accessible, but the result? Absolute peace of mind. Moving right along to Section 4. The secret is the right voltage. Now pay really close attention here, because getting the wiring right is where the true magic of this modification happens. The source material lays down an absolute golden rule. Connect directly to the battery line, B+ and B-, not the out points, to keep the raw 3.7 volts. To protect the sensitive electronics, we absolutely have to ensure the heater gets exactly the power it needs to spark the ignition, and literally nothing more. When you compare the 2 wiring options side by side, the difference is crystal clear. Using the out pins on the charging board actively steps the voltage up to 5 volts, which puts a ton of unnecessary strain on the heater. Dangerous, right? But wiring directly to the battery terminals, option A, yields a perfectly safe 3.7 to 4.2 volts. This perfectly mimics the natural voltage of the original D-cell batteries. All right, let's get our hands dirty. Section 5, Steps for Safe Modification and Assembly. The physical assembly is actually beautifully simple. First up, you just clear out the old metal battery springs from the box. Next, use a small blade or a soldering iron to carve a precise, neat slot for your new Type-C port. Then, solder your double wires directly from those B+ and B- points we just talked about straight to the heater's board. Finally, secure the charging circuit safely inside. When you're done, it ends up looking completely factory-made. Now, I absolutely love this pro tip right here. It says to use thermal silicone instead of standard hot glue to mount the circuit. Why? Well, while hot glue works in a pinch, gas heaters naturally get warm. Using thermal silicone ensures your new charging circuit won't just melt, unstick, and drop when the heater's ambient temperature rises. It's a small detail, sure, but it makes the whole mod highly durable. Oh, and before you close everything up, you really need to check the health of your repurposed battery. Always test your lithium battery with a multimeter first. A faulty lithium cell won't hold a charge properly, and it might even trigger a blue arrow light on your new circuit. What you're looking for is a red charging light. That means you're good to go. Always test before final assembly.
And hey, remember, electronics and bathroom steam, they do not mix. Make sure your freshly built power bank setup is tucked away from direct water steam, or just wrap it in a small protective case. It's super simple, but this one step will significantly extend the life of your brand new circuit.
Let's move to the grand finale, Section 6, Goodbye to Batteries and Power Cords. The contrast here is just staggering. Think about the old way. Messy hanging wires, reoccurring battery costs, terrifying shock hazards, and freezing showers during power outages. Yikes. Now the new way? You get a clean, wireless aesthetic, 100% safe, isolated, low voltage, zero recurring costs, and get this, it works flawlessly even during power cuts. For anyone relying on gravity-fed roof tanks, this is an absolute game changer. And as an amazing bonus, if you ever do happen to run out of juice mid-shower, you don't even have to wait. You can simply plug in a power bank and safely use the heater while it is actively plugged in and charging. Total convenience and complete 100% isolated safety. So, after seeing how simple, elegant, and cost-effective it is to completely eliminate the severe risks of 12-volt adapters and the endless annoyance of dead batteries, I have to ask, are you ready to upgrade your heater to the technology of the future and protect your family today? The tech is cheap, the steps are simple, but the safety it brings, that is priceless. So what's stopping you from making the switch?